Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. I left you guys off with how to form an ion. So a quick little overview of that first part. You realize that elements will typically gain or lose electrons in a fashion where they gain or lose the least amount in order to form that same electron count like the noble gases. Another trend you guys should have picked up is that for a given column, so for example this column, for the most part, atoms of a given column will have a similar charge ratio. So for example, fluorine, chlorine, bromine, iodine will all typically have a -1 charge. Oxygen, sulfur, selenium, tellurium, I believe, will all have a -2 charge. Nitrogen, -3. Other thing you should know for sure is aluminum will have a +3 charge. Silver will have a +1 charge. Zinc will have a +2 charge. This side here, for the most part, you will have in this column a +1 charge because they lose electrons. This column here, for the most part, +2 charge. Now in regards to the transition elements, transition metals, you can't really determine whether or not molybdenum or, for example, chromium will have a +2 or +3 charge in the fashion that I've been showing you with the metals and non-metals. It's hard to do with the transition elements. There's no way your professor or teacher is going to expect you to know the charge of, for example, vanadium. They'll basically tell you that charge, okay? And I'll get into that a little bit later. Okay, so just again, realize that for a given column, for the most part, they'll have typically the same charges. Okay, so for example, +1, +2, -2, -1. So for example, if we look at sodium has 11 positive things, has 11 negative things. In order to form its ion, it's going to lose 1 electron to look like neon. So now it has 11 positive things, right? 11 protons, and it has 10 electrons, 10 negative things. So 11 positives, 10 negatives, it's going to be a +1. Same thing with potassium, just to prove that for a given column you have the same charge. Potassium is not going to gain a bunch of electrons. Metals tend to lose electrons in a fashion where you lose the least amount. Potassium has 19 protons, 19 electrons. It's going to lose 1 to look like argon, right? So now it has 19 positive things. It has 18, because it looks like argon now, 18 negative things, 18 electrons. So 19 positive plus 18 negative is a +1. So +1, and sodium is a +1 as well. So there you have it. Just know that columns for the most part will have similar charges. +1, +2 column. -2, -1 column. Just know that for the most part, and all those other little small ones that I talked about too, like aluminum, this and that. Those are the charges you should know for sure. Okay, so zooming out, we're going to discuss how to form ionic compounds and some of the naming that goes into it. Okay, so ionic compounds. Ionic compounds are composed, as you should see by now, of metals and non-metals, right? Or it could be a transition metal and a non-metal, right? In order for these guys to form an ionic compound, one thing has to lose electrons and the other thing picks up those electrons. Okay, it should make sense. The naming, how it works, is exactly the way I've situated it here, but I further explained it up here. Let's look at it. Okay, so I said that in regards to the naming, you're always going to put the metal first and you don't change anything to it. Always the metal first. You don't put the non-metal here. It's always the metal first, and then it's followed by the non-metal, and you change the ending of the non-metal to IDE ending, ide. Okay, so for example, magnesium chloride, you see it's not going to be magnesium chlorine, that's going to be ide. You change that ine ending to ide ending. It could be sodium chloride, it could be potassium chloride. You don't change the metal at all, and it's always the metal first. Also, another little thing you should realize, that when we write ion, so for example, if your teacher says write out the magnesium ion, we know that magnesium carries a +2 charge when it forms an ion. Typically, notation wise, you put the +2 sign in the top right corner. That's just how it is. Okay, just realize that, and that denotes the charge. If it's on the top, it denotes the charge. Okay, if it's on the bottom, for example, just a little side note I want you guys to realize, if it's on the bottom, for example, like that, that is how many of those things you have of that atom. So this is not going to be the charge of magnesium, this is how many magnesiums you guys have. So 2 magnesiums. And yeah, that's pretty much it in regards to that. And again, this is known as a subscript. The thing on top is known as a superscript. Okay. Okay, so now let's move on to making ionic compounds. There's two possible ways in regards to making ionic compounds. There's one that's the hard way, and there's one that's the easy way. Okay, I'll go through the hard way first, so you guys get an appreciation for the easy way. Okay. So let's just say your teacher writes and asks you, write out the chemical formula of magnesium chloride, the way you would expect to see on a bottle of this specific chemical. Okay, so you're going to be writing it in its elemental symbol. Okay, so the hard way is as such in order to form the ionic compound. Well, what you do is write out magnesium chlorine. You would say that chlorine typically likes to gain 1 electron, as we have discussed. As we have over discussed by looking at the periodic table, and magnesium typically likes to lose 2 electrons, which will result in a positive 2 charge. But in this case, so basically magnesium loses its electrons and chlorine picks it up, okay, because it wants to gain it. But the problem is the capacity of chlorine is limited. It can only gain 1. Magnesium wants to lose 2. So there's unbalance. They're not really happy. They're not really stable yet, because magnesium is like, wait, I really want to lose both of them. You're not letting me lose them. And chlorine is like, hold on one second. I can't gain all of them. I'm so small. I can't gain 2 electrons. Okay. So what will happen is this chlorine will call out one of his buddies, one of his homeboys, and say, hey, why don't you come and help me out? Why don't you gain the other electron from magnesium? So effectively, you get 2 chlorines. And this guy could also gain 1 electron. And now everything is satisfied. The magnesium could lose both of its electrons, and one of these chlorines will pick up one, and the other chlorine will pick up the other. Okay? So how you would write this is as such. So you'll write magnesium, right? That's this elemental symbol, this chemical symbol. And you'll write Cl2. Again, even when you're writing out the chemical formula, it's always going to be metal first and non-metal. Okay? And when you draw or write an ionic compound, you're not going to put the charges here. You're not going to put +2 or -1. It's already understood that it has those charges. And again, this 2 on the bottom represents that you have 2 chlorines. Okay? So that's the hard way. That's the long-winded way of doing it. Okay? The easier way is as such. So you write magnesium and chlorine without the charges, or you could write it with the charges, but this is how it works. Okay? So you'll be like, okay, what is the charge magnesium likes to acquire when it becomes an ion? Oh, a +2. Oh, what is the charge that chlorine likes to acquire when it becomes the ion? Oh, -1. Okay. So, ionic compounds, just a side note, ionic compounds are, for the most part, neutral compounds. They don't have a charge. So in this case, you're going to try to figure out how many chlorines do I need and how many magnesiums do I need to have a balanced charge, so the overall net charge is 0. Okay, so you have 1 magnesium that has a +2, you have 1 chlorine that has -1. Well, in order to balance this +2, we need a -2. So why don't we put a 2 here, and we could write it out as magnesium chloride. Pretty simple. So now you have 2 Cl's that will equal a -2 charge, and magnesium has a +2 charge. Okay, let's go over another example. Let me erase this metal part to show you another example. So the easy way is nice and fast. Okay, we'll do some examples. And again, the ionic compounds I'm showing you right now are the most simple ionic compounds. We're not talking about polyatomic ions. That will be in a future part to this video, where I talk about polyatomic ions and transition metal elements and the naming that goes with those guys. Okay, so let's look at another example. Let's just say your teacher asks you to write out sodium oxide. Oh, hold on one second. Let's say that he asks you to write out cesium sulfide. He says write it out in this chemical form. Okay, we go through the hard way, but I'd rather not we do that. All we have to do is figure out the charges. Cesium typically likes to have a positive charge, right? +1. Sulfide typically likes to have a -2 charge, right? S2-. Well, how many cesiums do we need in order to balance out that charge? We need 2 cesiums, because now we have a +2, right? So effectively, the chemical formula will look like this. For the ionic compound will look like this. See, we have 2 cesiums. That little 2 represents that we have 2 cesiums, and we have 1 sulfide, a sulfur atom. Okay, we don't put the charges because we already know that the sulfur here has a -2 charge and the cesium has a +1 charge. But the whole point in doing this easy way is to balance out charges, and that's the easy way of getting the answer. Okay, let's do one more example before we move on to the bottom part. Let's just say your teacher asks you, says, well, give me the chemical formula for calcium oxide. Calcium oxide. Nice and fast, easy way. Calcium typically likes to have a +2 charge. Oxygen typically likes to have a -2 charge. Well, the charge is already balanced, so all we have to do to draw the product, or draw the, write out the answer, is calcium oxide. Nice and simple. You don't need to you don't need 2 calciums, you don't need 2 oxygens to balance it out. They're already balanced. The charges cancel each other out, so you have a calcium oxide. Okay, and there you have it. That's how you can go from the worded name of the specific ionic compound to the chemical formula. Now let's flip it up a little bit. Let's change it up, and we'll go from, if this fixes right quick, okay, let's go from the chemical formula to the name, to the written word. Okay, and I think I'll end the video at this, and then stay tuned for the next part where I discuss, I believe, polyatomic ions, and also, let's see, I discuss polyatomic ions and transition metal elements. Okay, so in this case we have NaO. Okay, we're going to use this thing up here that I talked about. Let me zoom out a little bit so you guys can see that. I talked about here metal and non-metal. Change the ending to IDE. So nice and simple. So we write the metal as the way it's supposed to be, sodium, right? We don't mess around with the metal name at all. We don't change the ending. The metal always comes first. And here's the non-metal, the oxygen, right? So we're not going to write it as oxygen. Instead, we're not going to write it as oxygen. We're going to write it as oxide. Right, we change the ending to IDE ending. So sodium oxide. So metal first, followed by non-metal. And let's see. Change the ending of the non-metal to ide. We can do the same thing here. We have K and Cl. And by this time you should have memorized all the symbols, the chemical symbols with the name. So you should know that this is potassium and this is chlorine and so on and so forth, and this is sodium and this is oxygen. You have to know that, okay? The other ones, like the transition metal elements, you don't need to know you don't need to know all of them, but you need to know at least half of the transition metal elements. Know for the most part all the non-metals and metals, and you should be good. Okay, so know how to go from the word to the symbol and from the symbol to the word. Okay, here we have KCl. So again, the metal, we just write it out, potassium, and then the non-metal, we change the ending to IDE ending, so chloride. And there you have it, potassium chloride. So again, stay tuned for the third part where I talk about those polyatomic ions and let's see, transition metal elements, and hopefully I'm going to try to squeeze in molecular compounds as well. Okay, so stay tuned.